Hello, Owen. Sorry you couldn't be with us today. But happy birthday.
That's Billy. Yeah, it's not Owen's birthday, it's Billy Owen's birthday. Restart.
Never mind, Owen. I got confused again. Today we're going to talk about measuring angles in radians. Measuring angles in radians. Radians, they're another unit measure for measuring angles. We've been measuring angles in degrees, right? So you can also measure angles in radians. Just like you can measure a segment in feet, you can measure it in inches, you can measure it in centimeters. There's different ways to measure a segment, right? So this is a different way to measure an angle.
There's another word that sounds like radians. I've never heard of radians.
Well, now you have. So, to me, the easiest way to remember all of this is that 360 degrees is equal to 2 pi radians. .360 degrees equals 2 pi radians. Okay? So if you start going backwards a little bit, and I'm going to show you two ways to convert, to go from degrees to radians and to go from radians to degrees. But for some of you, just remembering this, you'll find your own, you'll have your own way of doing the conversions, and it'll be shorter, faster, cleaner, simpler. So if 360 degrees equals 2 pi radians, then what does 180 degrees equal? It equals pi radians, doesn't it? Right? Because if 180 is half of 360, 1 pi is half of 2 pi. So 90 degrees equals half of a radian, or pi over 2 radians.
You can't say 0.5 radians?
If you want to. But it's going to be, you can do, like I said, I'm giving you the information, you handle it however you feel most comfortable. Okay, so you've got that in your notes, right? So let me give you one more picture. You got it?
Yep.
This was very helpful to me. Okay, let's see. We got a circle. And put a diameter in this circle. And 2 diameters. A vertical and a horizontal. And if we start right here, and we'll call this 0 degrees, and it's also 0 radians. Haven't gone anywhere, right? There's no angle measure. So we said over here that this was 180 degrees, right? Which is also pi radians. So up here vertically would be 90 degrees, agreed? And that was pi over 2 radians. So down here would be 270 degrees. All right, so look, if we went from 0 to half of a radian to a whole radian, right? What's this going to be down here in radians? 3 over 2 radians, right? Or 1.5. So this is This is how you'll see it, though. You'll see it as 3 pi over 2 radians. All right, so there's kind of a visual of it on the circle. And then back here, we can call this point 0 degrees, and we can also call it 360 degrees. And we said it was 2 radians. All right, so down on the bottom of page 816, it talks about converting angle measures. So converting angle measures. And degrees to radians. So degrees to radians. Multiply by pi radians over 180. That's your first conversion. So your other conversion would be from radians to degrees. And when you're going from radians to degrees, you're going to multiply by 180 degrees over pi radians. So look at the top of page 817. Convert to radians. You're going to convert to radians and you get 30 degrees. What do you multiply it by? 180 degrees over pi radians. That's not. Is that what I just told you?
No, you said pi radians over.
Yeah, it's the other way, isn't it?
Yeah.
Oh yeah, if you're converting to
Yeah, it's the other way. It's pi radians over 180. Now watch what happens here, okay? You gotta remember how to cross cancel. 30 goes into itself once, and it goes into 180 6 times. 1 times pi radians is pi radians. And the 30 was over 1, but it wasn't written, so 1 times 6 is 6. Alright, so pi radians over 6, or it's the same as pi over 6 radians. Whatever you're converting to has to be in the numerator. Okay? So you're going to be multiplying by either pi radians over 180 or 180 over pi radians, right? Whatever you're converting to has to be in the numerator. because that's the unit measure that's going to stick with your answer. All right, the denominators are going to get canceled out. So if you got 75 degrees, 2 radians, that means that radians go on top. So pi radians over 180 degrees. 75 goes into itself. Let's see, 75 doesn't go into 180, does it? 15 go into 75 5 times? 15 goes into 180? 12 times? So this simplifies to 5 over 12? Or 15 goes into 75 5 times, and 15 goes into 180 12 times. So that's about as simple as you can get it.
What do you mean by
Wait,
going to itself?
but it doesn't.
I'm sorry, 15 goes into 75 5 times. We're simplifying 75 over 180 with something that goes into both of them. What doesn't?
Okay, no, because that, wouldn't that be 15 though? 'Cause
Yeah.
15 times 12.
Yes, 15 goes into 75.
Okay.
No, it goes 5 times.
Yeah, it goes in 5 times.
But 5 times 12. No.
Wait a minute.
5 times 12.
We're not dealing with 12.
15 times 5 is 75. And 15
Oh,
times
okay.
12 is
Okay.
15 is a common factor for 75 and 180.
Okay.
It goes into both of them. You're trying to find the largest factor that goes into both, so you don't have to simplify again. You could have used 5,
Okay.
but then you would have had to simplify later. So 15 is the biggest number that goes into 75 and 180 evenly. So 15 goes into 75 5 times, and 15 goes into 180 12 times. So now your 5 times pi radians is 5 pi radians. And 1 times 12 is 12. So you'll see it as this. You'll see it more like this in the book. You'll see it as 5 pi over 12 radians. Make any sense?
Yeah.
You're either going to work harder to simplify in the first step, or you're going to just have to keep simplifying, or your answer's not going to be in simplest form. Okay? So now, if you're convert to degrees. Convert to degrees. And you've got pi over 4 radians. So we're converting to degrees, so that 180 degrees has to be in the numerator, and your pi radians is in the denominator. So see this pi radians in the numerator and the pi radians in the denominator? Yeah, they become ones. And 4 goes into itself once, and it goes into 180 45 times. So keep your degree symbol. So you did all your cross canceling, and you're left with 45 degrees. All the numbers were divisible. 2 pi over 9 radians. To degrees. So 180 degrees goes on the top, and pi radians goes on the bottom. So you see the pi radians right here on the top left?
Yeah.
That cancels with the pi radians. 9 goes into itself once, and it goes into 180 20 times. So 2 times 20 is 40 degrees.
So when you do convert it to degree, oh, it's always
Yeah, that's why if you get confused, whatever you're converting to goes in the numerator of the multiplier, because it always sticks. Got it? Page 817, 2 through 17. All conversions, and check headline for homework. I'm probably going to bundle together like this week's work. But everybody's been doing it, I'm sure.